You can record.
Good evening, everyone. And once again, I'm very happy to see every one of you. So today we'll be discussing three vital things, which is introduction to computer, internet, and Java. And on these notes, I will start by saying that Java is one of the most popular language that exists. Java is widely written and it is widely used for implementing internet-based applications. Let me come again. Java is widely used for implementing internet-based applications and software for devices that communicate over the internet. Over time, we see that the internet world has made things so easy for us that Java is also, they're widely used whenever we want to communicate from one end to another. And over 15 billion devices are being connected, are being run on Java. And also we have example of applications and programs that are being run on Java, that are being developed by Java. We have our Symbian phone. Symbian phone is an example. So I want to specifically welcome us once again to Java. And the example include, we have the smartphones, we have our smart appliances in the house, we have our ATM machines. All these are being developed by Java applications. And also, Java has three vital versions. We have the Java standard version, which runs on desktop. It is developed, it is contains the capability needed to develop desktop and server applications. Java Enterprise Edition is geared towards developing large scales distributed networking applications and web-based applications. So Java Enterprise holistically, they focus on large scales. They run on large scale network applications. So when you are developing, for example, we have Google, we have Facebook. These are networking applications that are example of enterprise edition that we can make use of Java for. Also, we have the Java Micro Edition. It is a subset of Java Standard Edition. Don't forget, I said earlier that Java Standard Edition contain the capabilities needed to develop desktop and server applications. So they have the capability to help us to develop our desktop. And what do I mean by desktop? Desktop is the same thing as computers, and server is a computer that is somewhere in the remote part. It's just like a computer that is in a remote place. Just like we saying that we have our accounts. We cannot see it with our physical eye, but whenever we go to the bank to deposit money, we discover that our account is credited, but we cannot say that, oh, this is the physical. We cannot see it physically. So this is a typical example of server. So like I said, Java Standard Edition contains the capability needed to develop desktop and server applications, while the Java Enterprise Edition is geared towards developing large scales, distributed networks. For example, I said Facebook. Most people, a lot of people use Facebook today. A lot of people use Facebook, social media applications. So a whole lot of people are connecting, they are communicating over it, over the web-based application, web-based, that we can use them on the internet, on the website. we can access the internet. Example is Google. Also, the third version of Java is the Java Micro Edition. So it is a subset of the Java Standard Edition that I made mention earlier. This is geared towards developing application for resource-constrained embedded devices. How do I mean? I am talking about our smartphones now. We can see that even in our homes, our appliances today, we can communicate with them. These are typical example of Internet of Things. They call it is known to be IoT, Internet of Things. Our smartphones, they operate in such a way that we can communicate with them. We can connect our laptop, our machine, our desktop to our televisions at home. They can serve as CCTV. We can use them for every other things, so many things. Even our smartphone, we can see that we can receive our phone calls with our smartphones. So these are what Java can do for us and beyond. So these are the three basic version of Java. So let me recap. I said Java has three basic edition. The first one is the Java Standard Edition, which contains the capabilities needed to develop desktop and server applications. Also, we have the Java Enterprise Edition. It is geared towards developing large scales, from the word enterprise, large scales, distributed network application, and web-based applications. So don't forget these three things. They connote the Java Enterprise Edition connote three things. One, the large scales, distributed networking applications, and web-based applications. Also, we have the third one is the Java Micro Edition, which is a subset. It's just a small component of the Java Standard Edition, which is geared towards embedded service devices. They develop the application towards the embedded services, which is having your programs that are running on small app, on small devices like your phone, our wristwatch, our television, and so on and so forth. I hope we get this. If there is any question, you can always reach out to me on this. So going forward, we'll be looking at computer hardware and softwares. Computers can perform calculations and can make logical decisions that are even faster than a human being. They can work, they can do things, they can do computation, mathematical programs that are even faster than human being. An example of the computer that can work on this is the supercomputer. In a second, they can work in quadrillions in just a second. These are computers that are built to actually process things, to calculate, to make logical decisions even faster than a human being. And one of the key words in the computer terms is computer programs. Computer programs are known to be sequence of instructions that we give to the computer in order to execute functions, in order to execute particular tasks. In the real world, there are a lot of instructions that are given. Like we can give our instructions like, oh, buy me food, buy me recharge card, get me something. So these are instructions. So this is also applicable to our computers that we can, so we call it computer programs. They are sequence of instructions that are given to the computer to perform or to execute tasks. And we can make use of our input devices. We are still going to get to that as we proceed in this course. Computer hardware include the physical part of a computer. That is what are visible. They are the things that we can see. They are the things we can touch. So computer hardware include the physical part of computer, such as the case, the central processing unit, the random access memory, that is our RAM, the monitor, the mouse, the keyboard, the speaker, the motherboard. These are the things that we can touch. These are the things that we can feel. These are the things that can be seen. So computer hardware, they are known, they are the physical part of a computer, such as the case, central processing unit, random access memory, monitor, mouse, keyboard, speakers, and the motherboard. Why the computer software is a set of instructions that can be stored and run by the hardware. Don't forget, I've defined what our hardware is, and I've given an example. They are the physical things that we can see. So to every instructions that we want to give our computers, so we have to input it. We can use our keyboard. So by typing our code, by running sequence of instructions, using our mouse, using our keyboard. So we are actually trying to transfer those instructions using those devices. So the devices that we make use of is the case, is the central processing unit, is the random access memory, which is our RAM, our monitor. These are the example of the hardware. Why the software? They are set of instructions. So they are computer programs that can be stored and run by the hardware. So what are the examples of the software that we have? It consists of written, machine readable programs. It consists of written, machine readable programs. Now you ask me, what is machine readable programs again? Now, when we are talking about programming, you see, computer has their own language that they understand. These are known to be binary codes, and they are zeros and one. Human being like you and I, we understand English language. Some understand French. Some understand all other languages. But the computer do not understand English, but to every instruction we are giving to the computer, they are being translated. They are being translated into machine readable programs. That is the binary number. They are known to be zeros and one that tell the physical components what to do and to execute these instructions. Let me come again. Computer software is a set of instructions that can be stored and run by hardware. It consists of written, machine readable programs that tell physical components what to do. Don't forget, they are telling our hardware, they are telling our keyboard, they are telling the central processing unit, they are telling the random access memory what to do. So these are the set of instructions that we give to our computers that tell them what and what to do, what to execute per time. And what are the examples? Example include our application software. Everybody on our phones, we all have different applications that runs through our phones. We have our Facebook. We have these are application softwares. Those ones that we installed. They are not something that we can actually tamper with. So application software, driver software. Driver software, they enable some functionalities within the computers. They allow the USB ports. For example, an example is we have the driver software that makes the USB port to function optimally. We have the middleware. We have the middleware. Middleware is an example. We have the OS, the operating system, the system software, the operating. Every system run on operating system. And the basic components of the operating system is the kernel. Kernel is an integral part of our operating system. Without it, there cannot be a computer. It's just like saying that without breath in a man, without blood, we cannot function. Without our brain, we cannot comprehend, we cannot think. So also is the operating system. And also we have the programming software. Programming software. So the example I gave is application software, driver software, middleware software, operating system. We have the programming software also. Now, going forward, we have computer organization. Our computer is organized. There are not things that they are well organized. And when I mean organization, it is divided into 5 parts, and they are very, very, very important. They are very, very important going forward. The first one is the input, from the word in and put. That means we are putting something, we are imputing something. This in quotes, receiving section. This is a receiving section. It is taking something in. It is receiving something. It's just like receiving a gift from a friend. So input, this is a receiving section, obtains information. So the opposite, the similar thing, the synonymous word that we can use for information is data. So wherever you hear the word data, it is similar to information. So data is the same thing as information, or we can call them computer programs. So they are the same thing. So we can either call them information. So they receive information. Input is when we are receiving information. This is receiving information section by obtaining information from input devices, and place it its place. We place it at the disposal of the other unit for processing. Now, let me expatiate this. Now, it's just like we are in the kitchen. We want to cook rice, and we have a helpmate with us, and we are just, the person gives us the rice that we want to boil. So we receive the rice, and while we are preparing it, we are cooking it. That is processing. Is that clear? That is processing. It's just like we receive food from maybe from a logistic man that brought food to us, and we process it by eating it. That is the typical example of input. Also, in our computer organization, we have what is called output. Output, this is shipping. This is shipping section. Takes information the computer has processed and place it on various output devices to make it available for use outside the computer. Don't forget, earlier I give an example of we preparing our food in the kitchen. Now, after we receive our ingredients, those ingredients that we needed to prepare our rice, that is the receiving section, we've input it. Now, we've prepared the food. Now we take the food from the kitchen to the dining to eat. That is what the information that has been processed, we are not giving it back to the outside world. This is a typical example of output. Another example is when we are typing on our keyboard using the Microsoft Word, and after typing the document, we type it, that is using our keyboard, which is an input device, to type on the Microsoft Word. Microsoft Word, don't forget, it is an example of what? It is an example of application. It is a software application. So are we getting those things together as I'm trying to give different examples? Okay. Now, after typing using the application that is called Microsoft Word, and we save it, and whenever we want to output it by printing it out using a scanner, using our printer to print everything that we've input into the computer. So that is output. So an example of an output device, it is the printer. So the printer is what they are extracting. They are shipping out the information that we have processed in our computer. Also, we have the memory. This rapid access, relative, it is low. We can look at this as a warehouse. We can call this as a warehouse where we store our goods. Well, for some of us that might not really understand what is a warehouse, it's where we store goods. And a typical example, or what is synonymous to a warehouse, is our store in the house, where we can keep our food stuff, where we can keep our things. We have our cupboard, we have our wardrobe, where we can keep our things. So memory helps us to store informations. Memory, they help us in storing information that we can process. So those information that we process, eventually they can help us to get it. So this rapid access is known to be a warehouse section. They retain informations. They help us to retain it, to store it. Every information that we have input, that it allows us to retain it, to store it, making it immediately available for processing when needed. So, like I said, using Control S on our keyboard make us to store information. Like after typing on our Microsoft Word, for example, we can decide that, okay, let me save it. So that means it is helping us to retain those information that we have saved. We can actually make reference to those information later. Either we want to edit part of it, like an example is I am using the PowerPoint, for example, and I save it using Control S. So after saving this information, now I can decide maybe the other time to go ahead to extract the information that the memory has retained for me, and to process it or to use it. Now, also we have what is called arithmetic logic unit. This is the manufacturing section. You know, I talked earlier about preparing food in our kitchen. So the process of me cooking the rice, mixing those ingredients together, igniting the fire, that is processing. That is, I am trying to manufacture things. Let me give another example so that we understand. In the bakery, we have so many ingredients that makes up the bread. We have our yeast, we have our yeast, we have our flour, we have our sugar, we have our salt, we have the water. They make use of water too. Now, the process of mixing these things together, putting it in the pan, putting it in the oven, in order for it to be baked, it is manufacturing. The arithmetic and logic. Logic talks about reasoning. While arithmetic talks about the calculation. This is just the simple understanding of it. Arithmetic and logic unit, which is known as ALU. This manufacturing section perform calculation such as addition, subtraction, multiplication, divisions. They helps in our decision making. Going forward, we'll be understanding a whole lot about this. So we want to make decision. The application of all those things, the applications. So they helps in making decision. Like we just press, we match on the brake, and the car come to a halt, come to a stop. That is what they helps in making decision. When we make use of our ATM, it gets processed and return onto us what? Money. That is decision. So this is an integral. It is very vital. We cannot take this away from the computer. Also, we have what is called the central processing unit. This is known as the administrative section. Administrative section. Because I call it administrative section because it coordinates and supervises the operation of the other sections. Every sections, they help in coordinating them. They help in the coordinating of every other sections. So a typical example is the brain. The brain, they helps in the coordination of every part of the body. As I'm talking to you now, it is my brain that helps in ensuring that what I'm doing is being allowed, that we can see, that we can touch, that we can feel. So also the system, the computer serves as the central processing unit. We can call it as the brain hub. This administrative section coordinates and supervise the operation of other sections. So every section that I have talked about, even the arithmetic logic unit, we can find it in the central processing unit. Yes, we can find them in the central processing unit. You know, for example, we have the aircraft. Aircraft have what is called the black box, and the black box is very, very essential. They are very, very essential because they coordinate and supervise the operations that is going on in the aircraft. So the central processing unit, this is the administrative section. They coordinate and supervises the operation of the other sections. The CPU, that is the short name for it, the CPU tells the input unit when information should be read into the memory unit. So now the input, the memory unit tells the arithmetic logic unit when information from the memory unit should be used in calculations. So they work hand in hand. So from our input to storing of information in our memory, so to processing the information in our arithmetic and logic unit, then having it back in our output. So this is a sequence. So the sequence move from what? From our input to everything we are putting inside our computer. We have our input. Also, we have what? We have the memory units that help us to retain the information. We have the manufacturing section, which is our arithmetic logic units that help us to what? To process these informations. If it is calculation, they help us to do what? To add up, to subtract, to multiply, or to divide. And when all these things are being done, they are given to us back as our outputs. Now, we also have the secondary storage unit. Don't forget, we talked about the memory unit. The memory units can be divided into two parts. We have the primary and the secondary. We have the primary and the secondary. The secondary storage system, this is longer term. Don't forget that the memory unit that we talked about, the first one, they are temporal. Their capacity is limited. But this secondary, they are flexible. They can take as many as possible. They are warehouse, whereby we can store a whole lot of information. So I call this a long-term warehouse section. Programs or data, they are programs or data not actively being used by other units normally are placed on the secondary storage devices. So things that we are not making use of, they are stored in the what? In the secondary storage unit. And the example of secondary storage unit, we have our what? SSD. SSD, you ask me, what is SSD? They are known to be solid state drives. Solid state drives. They can store information in a long time for us. Other example of secondary storage devices, we have hard disk, hard drives, that is the HHD, hard drive disk, HHD. We have the DVD drives. We have the USB. We have our what? We have our USB, flash drives. Some of them can take up to 2 terabytes. They can take up to 2 terabytes. They can take as many information as possible. They can take as many informations as possible. So, in summary, to everything I've said concerning the computer organization, so in summary, I talked about the input, which I call it the receiving section. They help us what? They help us to obtain information. They help in obtaining information. I talked about the output, which is our shipping section. They help us to every information. They help us to give it back to the outside world. So they take information from the computer to the outside world. I talked about the memory, which is what they have our memory. It is our warehouse that we use to retain information. Also, I talked about the arithmetic logic unit, which is known to be our manufacturing section. They help us to perform calculation, computations. They help in performing decision. decision. Also, we have the central processing unit. This is also known to be the administrative. So they are known to be administrative section. They coordinate and supervise the operation in other sections. So this is where the sequence of processing occurs. So after the input, it moves to the what? To the memory section where information is retained. From there, it moves to the arithmetic logic unit where our information are being processed and they are being extracted to the outside world. Also, lastly, we talked about the secondary storage unit, which is they have the high capacity, to high capacity warehouse, whereby they can store informations. They can store a whole lot of information, and their example of it is the solid state drive, the SSD, the HHD, the DVD drives, the flash drive, the USB flash drives. These are example of the secondary storage unit. I believe this class is getting more interesting, and I can tell us that as we progress, we'll have much interactive class also. So let's move to data hierarchy. Data hierarchy. So we are moving to data hierarchy. So hierarchy, from the word hierarchy, we've talked about data, which is the same thing as our information earlier on. I talked about data is the same thing as information. So also we have hierarchy of these informations. So we are starting from the least, which is our byte. Our bytes, bits. Bits is what they are known as. They are the smallest data item in a computer. They are the smallest data item in the computer, bits. So like I said earlier on, they are known to be the smallest. They are the least. They are the least. So we can assume them to be what? Zeros and one. They are zeros and one in value. So bits are zeros and one in value. They are zeros and one in value. So they are known to be zeros and one in value. So the Java, they make use of Unicode characters. Java make use of Unicode character that are composed of 1, 2, or 4 bytes. They are composed of what? 1, 2, or 4 bytes. Now, as we proceed, we'll be looking more and more about this. So now we have what is called field. Another one is field. We have what is called field. And field are composed of character or byte. They are composed of characters or byte. Are composed of character or byte. Now let me talk about byte. What is byte? Byte. So byte, we can say bytes so 8 bits makes up a byte. 8 bits makes up a byte. Don't forget that I said that bits, they are the what? They are the smallest. They are the smallest in the data hierarchy. And 8 bits makes up a byte. 8 bits makes up a byte. And when we compose, the combination of all these characters, they makes up a field. They makes up a field. So holistically, after we have the bytes, we also have what is called the field. We have what is called the field. So then going forward, we have what is called the record. And I must say something before I go on about byte, about field. A field is a group of character or byte that convey meaning. They convey meaning. They are group of character that they convey. Field convey meaning. Fields convey meaning. Now let me break it down. Like, what do I mean by character? Character is just representing one thing. We can say a character can be A. A is a character. It is just one, but A, just saying A, is not making sense. It's not telling us, like, it's not telling us, like, it's not giving a meaning, like A. What do I mean by A? But the combination of all these characters are known to be field. So field are composed of sequence of characters. So because they convey meaning, so we can say like alphabet, computer. In computer now we have so many character. The word, okay, computer. Now let me space it out for us to see. Computer. Now we have, these are known to be our C. Now C is a character. O is a character. M is a character. P is a character. U is a character. T is a character. But the combination of all these, so it is called field because it's convey meaning. So when we add them together, when we sum all these together, it gives us computer, which is a meaning. So this is an example of field. So the coming together of all these characters give us what is called field. I hope we understand that. So let me clean this. So, excuse me. The third one, we have record. We have records. We have records. So it is composed of several related fields. It is composed of several related fields. You can see that it's going from the simple, from the least to the complex. First, we have the bits, which are zeros and one. And we have what? We have the field. They are composed of characters. And I've explained to us what character means. They are what? Like a single alphabet, like A. But field, the combination of all these A, B, C alphabet makes a meaning. It makes a meaning. So that is field. And record is, it's composed of several related field. Several related field. It is composed of several related field. So how do I mean? Let me give us an example of what is called record. So record can be, example of record can be an employee details. Example of record is employee details. We can have your an example is our NIN details. NIN details. So it is an example of record because in it we can have our in it. It is composed because it is composed of our name. It is composed of name, address. It's composed of name, address, age. It's composed of name, address, age. We can have nationality. You can have religion. So the combination of all these, you can have your marital status. Marital status. The combination of all these, they are known to be what? To be records. They are known to be record. I hope we are getting that. If you have any question, you can drop your question for me. I'm more willing to be of help to any questions that we are having. Now we have what is called files. Files. Yes, we've had of files. To every of our documents, we have them in files. Anything we are storing on the computer, we have files. We have files. Now, a file is a group. Don't forget that keyword. A group of related records. If a file is a group of related records. Related record. A file contains arbitrary data in arbitrary format. It is a sequence of bytes. It is very important you note this. It is a sequence of bytes because you have a whole lot of bytes. So a file that contains arbitrary, excuse me, a file contains arbitrary data. They contain arbitrary information. Don't forget, information, that is data, in arbitrary format. Now, I am presenting to us using PowerPoint's presentation. Now, if I save this thing, it is a file because they compose of a group of related record. We can say this is one record, this is this, this is this, this is this, this is another one. So the grouping of all these together, when I group all these ones together, they makes up a file. They makes up a file. So a file is a group of related record. It is a sequence of bytes. Don't forget, I've explained what a byte is to us, that 8 bits makes up a byte. 8 bits makes up a byte. Also, going further in this hierarchy, we have what is called database. We have database. And database is a collection. Don't forget those words. They are very, very important. A collection of data that is organized, that is organized for easy access. But in all, what is database? A database is a collection of data that is organized, not only organized, that we organize, that can be stored and updated. We can update it. It is a collection of data organized, stored, and we can update them for easy access, so that whenever we want to make reference for it, for easy access and manipulation. That is, manipulation is just like saying that we want to update it, we want to edit it. That is the same thing as manipulating them. That is just like saying that we want to manipulate them, we want to edit them. So database is a collection of data organized, stored, updated for easy access and for manipulations. It is very, very important that we note all this. So we can store them in tables. Example of data of a database. Let me give us an example. An example is we have the MySQL. So this is an example. We have MongoDB. Let me just, I will not expatiate on this because we will not, it's outside the scope of what we are learning. We have the Cassandra. So we have a whole lot. We have the Postgre. So these are examples of the database. So they can be stored in tables, they can be stored in graphs, we can store our information in graphs, we can store them in tables, and tables consist of rows and columns. They consist of rows and columns. Also, we have what is called big data. You'll be wondering, what is big data? So it is the amount of data. This is the amount of data being produced worldwide. You know, the amount of data that are being produced worldwide is enormous and can grow quickly. No, the amount of data, this is information. Don't forget, I said earlier that data are known to be informations and they grow extensively over time. Like I said, that we have a supercomputer. I've reiterated this earlier, that in a second they can predict, they can process quadrillions of information in a second. So, and we have big data. So the list of them, of these big data, it is kilobytes. It is kilobytes. So the list of them, of the big data, it is known to be what? Kilobyte. List of data is kilobytes. So what do I mean by kilobytes? Kilobytes are just 10 raised to power 3. So example of kilobyte is 1004. This is an example of kilobyte. We also have megabyte. So anytime you hear kilobyte, some will write it in full like 1024. It is kilobyte. Or some you'll see it in some places whereby they'll say 10 raised to power of 3. 10 raised to power of 3. So they can write it in this form, that 10 raised to the power of 3. So this is the list of data that we have. Don't forget, we also have, after this, we have what is called the megabyte. We have the megabyte. So after this, we have what is called megabyte, from the word mega and from the word kilo. Kilo is small. We have megabyte. So the list, this is 10 raised to the power of 6. Don't forget, the kilobyte is 10 raised to the power of 3, and we have the the megabyte is 10 raised to the power of 6. Yes. So we also have the gigabytes. Gigabytes is more than the megabyte. That is 10 raised to the power of 9. 10 raised to the power of 9. That is gigabytes. Also, we have the terabyte. Terabytes. I know that, yeah, for some might be familiar with this, but for those that are just beginners, this is, like I said, this teaching is for absolute beginners. We don't know much about the computer and those words. Terabytes. So these are the sequence. So from kilobytes to, so from kilobytes to megabytes, from megabytes. So you have from kilobyte to megabyte, from megabyte to terabyte. From kilobyte, so we have the megabyte too. So from terabyte, we have what is called petabyte. Yeah, that's the petabytes. Most people might not be so aware of this. That is 10 raised to the power of 15. That's the petabyte. Yeah, that's petabyte. So this is going forward. These are the things we'll be learning. And we have the exabyte. Exabyte. That is 10 raised to the power of 18. 10 raised to the power of 18. I hope we are getting something. And the boss of them all is the zettabyte. That's the zettabyte. Yeah, that's the zettabyte. So that's the zettabyte. That is 10 raised to the power of 21. 21. Do we notice something that we can see that from here we can see that the power is incrementing by 3. First, we have 10 raised to the power 3 for the kilobytes. For the megabyte, we have 10 raised to the power of 6. To the gigabyte, we have 10 raised to the power. They are incrementing in threes. They are incrementing in threes. We have 10 raised to the power of 9. Also, we have the terabyte, 10 raised to the power of 12. Petabyte, we have 10 raised to the power of 15. And we have the exabyte, we have, that is 10 raised to the power of 18. And we have the boss of them all, which is the zettabyte, which is 10 raised to the power of 21. That is the highest in the data, in the big data. I hope you are learning something new. Now we'll go to what is called machine language. Let's discuss. We'll be discussing machine language. So let's discuss what is machine language. Now, from the word machine. Machine language, it is generally consist of strings of numbers. It is generally consist of strings of number, that is zeros and one. So you know why I was discussing with us before, we talked about what is called the machine language, that as we understand zeros and one, so also computer, they have their own language. They only understand they have their own language, which is zeros and one. So machine do not understand any other language aside this. They do not understand any other language aside the zeros and one. So this is typically, so how do I mean by zeros and one? That, and to everything we've been writing, we write in English now. Yes, we write them in English, but do not forget that we translate them. We translate them. So machine language it generally consists of strings of numbers. So what I mean by it is 0, 0 and 0 and 1. So you cannot put 2. Machine do not understand 2. They don't understand 2. They are machine dependent, meaning a particular machine language can be used on only one type of machine. It means that they can only be used on one type of machine. So their machine language, they are known to be what? Machine dependent. We also have another one that is called the assembly. The assembly language. You'll be wondering that what we know is English, French, Spanish, but this is computer word, so they have their own word. So this is just like, this is English-like. It generally consists of English-like abbreviation to represent elementary operations. It generally consists of English-like, don't forget, very important, English-like abbreviations to represent elementary operations. So assembly are known as translators. They are known as translators. So what do I mean? Now, a situation whereby someone that do not understand English, that only understand French, and we have someone that we go ahead to go and hire someone to do what? To translate. So assembly language, they are known to be what? To be translator. So they are translator. So they translate programs. So they help to translate programs to machine language. So are we getting the concept? Because I told us earlier, you'll be wondering, why do we write programs? Because the programs we are going to write too, every code, every Java that we are going to write using our English, normal English. But we'll be wondering like, how do computer now understand? Because I say that the only language that the computer understands are zeros and one. But with this assembly language, they are known to be translator that helps to translate every of our English-like abbreviation, English-like words that we've written. Also, we have what is called the high-level language. The high-level language. High-level language and compiler. Now, compilation. After they store and they release it to you. I will be given a physical example. Now, in churches, my pastor is preaching in English. We have some people that they are interpreters. They will be interpreting maybe in the indigenous language that people will understand. And if you look at some of our religious references, like Bible, like the Quran, they are being translated from Hebrew to English. They first compile them. Then they now translate them to the language we can understand, which are English. So this high level language and compiler allow you to write instructions that look almost like everyday English. So that looks like everyday English. So, but there are two things that are involved here. So under the hood, they help us to compile it first. Then they now translate it to what the computer will understand, to every language that the computer will understand. So it allows you to write instructions. Don't forget, the instructions are known to be what? Computer programs that look almost like everyday English. And everyday, made a mistake, everyday English, and contain commonly used mathematical notations. Like these are our additions, subtractions, multiplication. So to speed the programming process, high level language are developed. Instead of an interpreter to first interpret, someone that is speaking will have to wait, will have to pause. But now everything has been automated. So the high level language, they have automated in such a way that you don't need to first compile, after compilation, then you have to compilation is, you have to take it from the language, from that English language to byte codes. Then from byte code, you now translate it into what computer understand, which are zeros and one. But high level language they have solved all this in the wood. So like I gave a typical example that to every religious beliefs, every faith, like we have the Bible or the Quran. So they are written in Hebrews. So they translate it in such a way that we don't need to start thinking of how to just go and be looking at to go and search for the meaning. So they have compiled them. That means they collate them together and they translate it into into the language that we understand. That is what the high level language does in the wood. So we have interpreter. Like I said earlier on, interpreter, we can find them in our religious cycles, that they interpret maybe to the indigenous language of people while the pastor is preaching. And don't forget that this might in one way slow down the preaching of the pastor, because the pastor needs to wait for the interpreter to interpret before he proceed. So interpreters, so they are known to be what? Interpreters. It is developed to execute high level language. So here we find, in this high level, we find what is called the interpreters. So they are developed to what? To ensure that high level language they are being executed directly. They are executed directly. Interpreters enables high level language to execute directly without first going to compile, and so it helps to avoid compilation. So it avoid compilation, like compiling. It avoid compilation. It's avoid compilation. It's avoid compilation. So they helps to ensure that all this thing is done in the wood for us, to ensure that everything is done in the wood for us. And over, I will briefly go ahead to summarize what we've learned today for those that they didn't catch up earlier in the course. So by the time we are meeting next time we are meeting, we'll be discussing we'll be looking at introduction to object technology. They are very, very important. They are very, very important. We'll be looking at them, and from there we'll proceed. Like I said, it is beginner friendly, irrespective of your background, irrespective of where you are coming from. I can assure you that once you are consistent, you not have issues. Now, I said that computer basically they understand a language which are binary codes, and binaries are zeros and one. They are zeros and one. So to every instructions, to every computer programs that we are writing, we must ensure the computer don't understand them, but there are things in the wood that converts. The bytecode helps in the conversion of our English like words into machine code that the computer understand for the execution of the instructions that we've given. So also, I talked about the data hierarchy. I said that data hierarchy, uh, data hierarchy, they are they are information that are in a stepwise, from the least to the highest. And I talked about the bits, which are zeros and one. And I said that 8 bits equals to, they makes up a byte. 8 bits makes up a byte. So we'll be looking at data types as we go on. There are a lot of data types too. Hierarchy is different from data types. And bytes, like I said, there are zeros and one. We also have field, are composed of characters and bytes. They are known to be what? Field convey meanings. They give meanings. And I said that character, they can be a single value. They can be A. This example of character is C. Example of another character is O. Example of character is M. Example is P. We have P, we have U, we have T, we have E, and we have R. So, but when they come together, they are known to be field. When all these come together, they are known to be field because they give meaning. They convey, don't forget, said field convey meaning. They give meaning. So, but a character is just a single thing like C, O, N. They are known to be a character. And record, I go further by saying record. It is composed of several related fields. It is composed of several related fields. And I gave an example of your NIN. On your NIN, you have your words, you have your name, your age, your address, your nationality, your state of origin, your marital status, and all that, so forth and so on. So the coming together, the record is composed of several related fields. They are composed of several related fields. So, and also we look at files. A file is a group of related records. A file is a group of related records. It is a sequence of bytes. It's a sequence of bytes. So if an example is, now, if I'm having 5 employee, now I'm having their record. So having their record their record. That means I'll be having their record. So the group of their record is known as files. Don't forget, I'm having 5 employees that have record. And in the record, we are having their name, their age, their nationality, and so forth. So it's giving us their details. So if it is giving us their details, that means a file is a group of related records. And we also have, I talked about the database. A database is a collection of data that is organized, stored and updated for easy access, and manipulations. So, and I gave an example. We can, like I said, we can edit them, we can manipulate them, we can edit them. We have an example of MySQL. We have example like MongoDB. So, and we also talked about the big data, which are we look at data are informations, and we look at from the least to the complex ones, from the kilobyte to the megabyte, from megabyte to the gigabyte, from gigabyte to the terabyte to the petabyte, then to the exabyte, and to the zettabyte. So these are what we've learned so far today. But you feel free to reach out to me if there are questions, if there are things we find it challenging. I'll be willing to answer those questions. And I hope that in the next class we find it much more interesting too. So ahead of the next class, I want us to read ahead. So I want us to read. Let's look at what is we'll be looking at introduction to object technology. So let's look at them. We'll be looking at operating system. For us to be ahead of class, we can just look at what is we'll be looking at what is we'll be looking at importance of Java. Let's look at Java. Let's read more on Java. So if you find anything challenging, you can reach out to me. Let's look at the phases. There are phases in Java. So let me just give us an hint. We have the edit phase, we have the compile phase, we have the load phase, we have the verify, and the execute phase. So these are the 5 phases in Java. So I want us to read ahead of class, and I hope to see us later. So thanks. Have a great day.